Okay, so thank you guys for joining. I'm here to talk today about AI-powered lean. This is an interesting webinar for us because it's really the first time that Drishti has started to open up and tell people what we're really doing under the hood and how our customers are benefiting. And actually, next week we are making a major announcement that I can't talk too much about, but suffice to say, we're going to be opening more and more up about what we're doing and how actual customers are benefiting from the product that we're doing. But today we're going to give a pretty deep dive, definitely deeper than we've done in public before. It should answer a lot of the questions that people have. So let's start this story talking about this guy. This is Andres Galarraga. So I told you I grew up in Denver. On July 3rd, 1995, I actually went to this game where Andres Galarraga went 6 for 6. And it was a really incredible game. Now, the reason why I bring this up is because as you probably are doing your lean manufacturing, you're saying, let's go look, let's take samples and see how our system is doing. So you go out to the floor with your stopwatch, you take a bunch of samples and you say, this is how our system is performing. So if I were to go to this game on July 3rd and look at the 6 sequential at-bats that Andres had, I would say, well, if I extrapolate, he's gonna hit 1,000 for the entire system, for the entire season. Now, obviously he didn't do that. He went 280 that season, which is not bad, but it's certainly not hitting 1,000. And the reason why I bring this up is the core problem with lean today is that the data you use to make your really big decisions is biased by the size of the sample. And it's also biased by observation. We'll talk about that in a second. But having a small sample size leads you to make very wrong decisions about what's going on. The challenge is it's very difficult to get data at a large enough sample size to make more accurate decisions. So the question that Drishti is here to solve today, the reason why the company exists, is how do we improve human performance at scale? And the way we do it is to digitize assembly activities. In other words, to take what people do and create data. We have a really incredible stack of technology with AI at its core that does this, but that's not really the purpose. The purpose is to create data. And what you'll talk about today is, or what I'll talk about today, is the data that we are creating and how customers are using this data to drive real change. A little bit about the company. It was founded about 4 years ago. Our CEO, Prasad Akella, came from GM and SAP. So he's combining manufacturing plus data. I joined about 3.5 years ago. I'm employee number 3. We're about 45 people today. Over the last 3 years, we've had some really interesting and great people in our corner. The World Economic Forum has named us a technology pioneer last year. They do this for companies that they think have the potential to change humanity, which is quite an assertion, and we're very excited to have that. And the reason why, and it's actually the same reason on the right-hand side, the NSF, the National Science Foundation, has given us a grant, because these organizations believe that the data we're creating can help the individual workers as well as the businesses. It's a rising tide that can lift all boats. So we'll talk quite a bit about that in a second, how both the businesses and the operators benefit from the data that Drishti creates. So a little bit about me, head of marketing business development, employee number 3 I mentioned. I also worked at SAP. I worked at a company called WPP when I lived in New York. It was a big advertising agency on Madison Avenue. I went to Syracuse where I learned how to live in the cold before I lost my ability to live in the cold. I like to do trail running. So if I ever come out and visit your factory, I will probably ask you where's the best place to go to find some training and some trail running. Actually, when I was out in Moline, I actually went and ran some trails over there. So good to have memories of Moline. Glad to see you on the line again. And then I'll make subtle Star Wars and Seinfeld references. I don't have any planned. They kind of come up organically. So if they should come up, and also Simpsons references as well. So if you hear any, feel free to raise your hand and say, hey, I caught that, and then we'll share a good laugh. Okay, so today's agenda. What's wrong with lean today? How can AI improve lean? And then what we're already all really here to see, which is real customer stories of AI-powered lean. Now, it's a bit of a dramatic, kind of intentionally provocative statement to say there's something wrong with lean today. It's not the methodology, it's the data. So we did some research with A.T. Kearney. You guys may know A.T. Kearney. They're the big management consultants, global management consultants. When CEOs of Fortune 500 companies have a problem, they call A.T. Kearney to solve it. So we worked with A.T. Kearney to really understand what is going on with manual activities inside of factories? Because there's a lot of buzz around Industry 4.0 with machine data and machine data streams. But what we learned after we talked to 100 factory leaders is that manual activities actually make up about 72% of what happens inside a factory. It obviously depends on the region. It obviously depends on the product. Some are more automated than others, but across the aggregate, manual activities are still far more critical in manufacturing than most people outside the industry, and even a lot of people inside the industry, really understand. Now, at the same time, we're creating 72% of the value, but human beings are also causing 69% of the defects. So people are the most critical element of the system, both in terms of value created, as well as in terms of the problems created. Now, it's easy to get machine data. You know, I've got a stamping machine. It's fairly easy to convert even the most analog stamping machine into something that creates a data stream. But when you have people doing things, it's extremely hard to get data. So in fact, for 100 years, this has been the best tool. 100 years ago, Henry Ford had to turn a bunch of farmers into effectively a machine that can make cars. And they did so by standardizing the data using the time and motion study. 100 years later, we're still all using time and motion studies in our factory. And this is problematic for a couple of reasons. One, if I'm creating data manually, then I'm not going to get a big enough data set, because I got to hire somebody to stand behind somebody to figure out how long they're taking to do any given task. And we see this all the time. Process engineers running around either with their stopwatch or with video that they'll take back in time later on their desk. But either way, you get a very small data set. And as I talked about up at the top, when you have a small data set and you try to make big decisions like staffing or resourcing or supply chain, or do I need to build another factory? If you have a small data set, you're going to make skewed decisions. And the second thing is, if my boss was standing behind me right now, observing my webinar and judging it and taking notes on it and timing it, I would probably be doing very differently than I am knowing that he's not listening, and I can talk about things like Star Wars and Seinfeld. So there's observation bias on both sides. The operator knows they're being observed, and so they behave differently. But also the person observing the behavior might be making decisions different than the next person who comes along timing. So I might say the cycle starts with X. The other person might say the cycle starts with X plus 1 second. Whatever it might be, it distorts the view of the system, and you still don't have a whole, reasonable view of what's going on. So in summary, what's wrong with Lean today? You lack the data on the thing that matters most in your factory, which is those manual activities. And so the question is, how can AI improve Lean? Well, before I can answer that question, I have to answer a question, which is, what is AI? A lot of people, when they hear AI, they think it's going to be droids like C-3PO. That's not even a reference. That doesn't count. They think there's going to be droids like C-3PO or Rosie from the Jetsons, or they think it's going to be computers that are taking over our jobs, and we're just going to be like the people in that movie WALL-E, where we're just sitting in chairs consuming. All of these misconceptions about AI are really quite far from the truth. The truth is that AI is really good, but not perfect, pattern recognition. I think in my last webinar I went into it. I'm not going to talk about it this time, but basically AI is teaching a computer to recognize patterns. In the case of Drishti, we're teaching the computer to recognize patterns in human manufacturing. It's a simple statement. It's very hard to do because, as we all know, the patterns change depending on the operator, depending on the time of day, depending on the operator's left-handed or right-handed, big or small, if the operator is tired in the morning or hungry before lunch or full of energy after lunch. These all change the patterns. And so to come up with AI that can be robust to all of these changes is not easy, but it's a very sophisticated way to solve a simple problem, which is, how do you find the patterns that matter? And more importantly, how do you find the outliers that contribute to variability? So what does Drishti do? How does Drishti work? Before I get into the use cases, I just want to give you a little bit of a sense of what we're up to. So we put in cameras. We're a computer vision-based company, and we capture video of the manual activities at the workstation. We transmit that video to the cloud, where we use AI to turn that video into stream of time and motion data. Again, our AI is a very sophisticated way to do what a process engineer does, which is observe what a person's doing and create that time and motion data on top of it. We do it continuously, which is, as you'll see, extremely significant. Then we take this data and we feed it back to the people inside the system. And there's a lot of consumers for this data and a lot of different ways to use this data. And we'll talk about this for a second. Quality engineers, process engineers, supervisors, plant management, the operators themselves, trainers, everyone's going to use this data in different ways to achieve different results. And as we'll talk about in a second, our customers find a lot of different ways to improve their productivity, their quality, and their training velocity using this data set. And because every factory is different, every factory ends up with different use cases, but having the data is really what we're seeing with our customers, a significant, I mean, game changer is a cliche, but that's what it is. So in summary, traditional lean, you have episodic manual data creation, which means you don't have enough data, and the data you do have is biased either by the size of it or by the observation bias. What we're doing is we're giving you continuous data creation done digitally. In other words, there's no manual effort required once it's set up. Every cycle creates data, and because every cycle is creating data, you don't have that observation bias. So I want to give you the first of many tangible examples. Each of these dots on the screen is a cycle that was observed at an actual customer. This is a electronics contract manufacturer customer in Mexico. So we took about 12,000 cycles, 11,000 cycles, and we plotted them on this kind of plot. So you can see the distribution. And on the left, you see the average cycle time. So the customer, if they were to measure cycle time, they would go out there with their stopwatch and they would measure 10 sequential cycles. We know this because that's what they told us. This is how they do it. 10 sequential cycles and they'll know cycle time. So if they were to pick these 10, and we picked 10 randomly in a row, they would say that the cycle time was 111 seconds based on this cycle time. They might throw out this one, even though that was a real cycle. It might have been reworked, but it was real. They might throw that out and get some other number, but regardless, you pick 10, you're going to say it's 111 seconds. Or you pick 10 on this day, and you're going to say it's 94 seconds. Or you pick 10 on this day, you're going to say it's 116 seconds. And that's the point. So now you can see that you take any 10 samples in a row, and you're going to have very different measures of cycle time. And this is the critical point. The problem with lean is you don't have enough data, and you're making your decisions based on a flawed data set. Now, we look across these 12,000 cycles over the course of this month or two. We don't have the observation bias. We don't have the worries of sample size. And we know that their true cycle time is 108 seconds. And what we help this customer understand is when you know your true cycle time, you can see if your lines are actually balanced. You can understand what the variability is, and you can figure out where the variability is coming from. You can see which station it's coming from. You know how many people you have to hire. You know what your output's actually going to be. You can determine if you need to spin up another line or build another factory and predict all your costs. All of these better things start to happen because you have better data. And we'll talk all about that in a second. So I'm ready now. We're at the good stuff. We're going to talk about actual customer use cases. And we're keeping an eye on the questions. So if you have any questions, just feel free to type them in the chat box. So how does Drishti create ROI? So even though we have a million use cases, like I've talked about, really it boils down to two major ways that ROI is created. Through production optimization, in other words, either getting your process leaner or increasing your plant capacity. So cost reduction or increased throughput. And then defect reduction, systematically finding ways to help your people adhere to standardized work. And I'll talk a lot about that in a second. In fact, I'm going to drill into these three use cases that are circled on the screen. But I want to keep, what I'd like you to keep in mind is that these use cases all boil up to either better quality or better productivity. And I won't talk too much about it today, but also training acceleration, getting people, new people to the line faster. So let's talk about this. Identifying bottlenecks, imbalances, and variability. How do we do this? So like I said, we train the AI to automatically measure every cycle that's performed. And we feed that data back to engineers, supervisors, and operators. So how do the engineers use this data? Let's start with the engineers. The engineers, their goal is to improve the system, to find the imbalances and find the variability and get them under control. And so what we do is we give them analytics dashboards where they can take these cycles that we're measuring on a case-by-case basis and look at them in the aggregate. The obvious one, for example, is line balance. And we'll talk about this visual in a second. But what this means, so we benchmarked this in a couple different ways. With A.T. Kearney, our research found that something like 30% of the engineer's time is spent just creating data with their stopwatch. We have some other customers who benchmarked it, and they say 40% of the engineer time is spent gathering data. Either way, with Drishti, these engineers get that 30 to 40% of their time back immediately. So imagine your plant, suddenly you've got 30 to 40% more engineers out there solving problems. And not only that, they're solving problems better because the data they have is free from the observation bias and doesn't have the sample size distortion. Now, the other cool thing that starts to happen is when you have volumes of data like this, you can actually do things that you've never been able to do in a manufacturing environment before. For example, you can filter your cycle times by date, by shift, by time, by product, etc. So what you're seeing on the screen on the right is cycle time across 3 different shifts: first shift, second shift, third shift. Now, everyone kind of knows that the third shift behaves differently because all the engineers have gone home, all the management has gone home, and they're kind of left to their own devices. What we've seen in our customers is that the third shift ends up coming with very creative ways to solve the problems that the first and second shift doesn't do because there's so many people running around looking at what they're doing. And so here we actually benchmarked what was happening on the third shift. We used our data to not only figure out that the third shift was more efficient, but to figure out what in the process was driving their efficiency. And this actually leads us to this idea of A/B testing. So if you're on Amazon, you'll see that the buttons are green, the button to buy, or maybe it's orange. I don't remember what color it is. But there's a notion in the website world called A/B testing, where I take 2 variables, I do a side-by-side test that runs with a very high volume of data in a very short period of time, and whatever the winner is, I implement it. So if Amazon wants to know whether a green button or a red button is more likely to convert, they just run a test for an hour. At the end of an hour, they have the data to show that red works better than green or whatever it is, and they say, all right, we're gonna do that. That's the new process. This becomes possible in a manufacturing line. It's true continuous improvement. Hey, let's have shift 1 do the process this way. Let's have shift 2 do the process that day. At the end of the day, we'll know which one's better, and we'll change the process, and we'll start it all over again the next day. Or it doesn't even have to be shift. It could be by rotation, going rotation by rotation to find the more optimal way. So the way our customers see ROI depends on the plant. Some of them increase their capacity. Some of them are looking at reducing their cost. Either way, it's very significant because when you combine the opportunities for improvement, you can seize them for big results. Here's an example. We have another contract manufacturing customer where they told us all our lines are balanced and all our processes are optimal. Well, we did some data collection using our system, and we found they had, in most cases, depending on the line, from 19 to 28% productivity opportunities sitting on the table. It wasn't that they were doing a bad job. It's just they did not have the data to understand what the truth was. When you have 1,000 samples versus the 10 samples they had, you can find the opportunity. It really is just that simple. So that was process engineers. Now let's talk about supervisors. Supervisors are also interested in cycle time, but they're not necessarily interested in the trends over time. They're more interested in the shift. What is happening in this shift? How can I solve problems in this shift to make sure I hit my shift targets? How can I help the next shift by making them more aware of what happened on this shift? And so for these guys, we can take that same cycle time data and feed it back to them in a dashboard that lets them see unit by unit what's happening, updated regularly throughout the shift. So this graph is a representation for those of you on the line who have seen our actual product. You know that this is what's in the product. You see the bottleneck cycle time of every single unit. Now the red is when the bottleneck cycle time spikes. Now what happened at that bottleneck cycle time? The supervisor typically will become aware of a bottleneck sometime after the bottleneck occurs. The first thing we can do is we can have the supervisor be more aware sooner of when the bottleneck is. So once the supervisor is aware of a bottleneck, they'll spend, let's say, 20 minutes trying to figure out what is the root cause. Where is the system failing? Is it a materials problem? Are we missing tools? Are we missing parts? Is an operator not trained in a certain part of the process? Whatever it is, they've got to figure it out. In the meantime, the line is stopped or the line is slowed. People are getting upset. I could make a Seinfeld reference right there. People are getting upset. George is getting upset. Everyone's getting anxious, right? This is what happens in the line. Tempers start to fray, and the supervisor will say, okay, that's the problem right there. The supervisor might be right. The supervisor might be wrong. And if the supervisor is wrong, then an operator might be very annoyed, or the materials people might be very annoyed. Now, with Drishti, you have video backing the data of where the bottleneck is. And so when that happens, the supervisor can just watch the video. Even as they're walking to the problem, they can be watching the video, and they can understand better what's actually happening, because they can see back in time. They can see 5 minutes ago to when the thing actually happened. That lets them get to the bottom of the solution faster. So just like with process engineers, the time they would spend creating data, they get that time back to instead solve problems. The same thing goes for supervisors. They can very quickly understand the root cause of the problem and become that much more efficient in deploying the appropriate countermeasures to keep the line running smoothly. What does it mean to have more predictable shift output? It means less overtime, means fewer defects. It means improved line morale because we're not scrambling around pointing fingers at each other. It means more effective shift handovers because the supervisor from shift 1 can take this data, show the video to the supervisor from shift 2, and they can get to the bottom of it and make sure that thing doesn't happen in shift 2. Excuse me. Webinars make me thirsty. So a supervisor becomes basically 4 times more effective. Now, the third user for this kind of data is the operator. It depends on the line, but we've seen a lot of long cycle lines where the operator has very little feedback as to whether they're hitting their target cycle times, whether they're going under, whether they're going over, that kind of thing. What we've done is if we can give the operator feedback about their cycle time very soon after the cycle is finished, then they have more awareness of what they're doing right and what they're doing wrong. So in particular, we have one customer where their cycle's about 150 seconds in the station. When the operator starts to go to 180 seconds or whatever the case might be, Drishti will come up and say, hey, check your time. And the operator will realize, okay, I'm going too long. And what we see is that variability gets reduced. It's actually very simple. If I know how long I have, then I'm going to do my job better. I'm going to do my job faster. And so for these guys, they've actually seen a 9% productivity boost, but just by giving the operator awareness of when they're going long. So let's just double click on that because that's really interesting. The operators got 9% more productive. In other words, they were 9% more efficient simply because they had awareness of when they were going long and were able to put in their own countermeasures when they had that awareness. It's actually a pretty incredible finding, and we're very excited about that. Okay, so that's kind of a taste of how we're identifying bottlenecks, imbalances, and variability. So let's talk about Kaizen, accelerating Kaizen frequency and improving outcomes. So there's this notion of continuous improvement in Toyota Production System, but we also have this notion of the Kaizen event. I have this theory that the Kaizen event is actually kind of a reaction to the fact that continuous improvement isn't as pervasive as the industry says. So if you're not continuously improving, you got to bring everyone together to do a Kaizen event to figure out the problems on the line. It's a very intense 5-day event with 10 people. And that I think happens because you just don't have the data to do continuous improvement on an ongoing basis. So what we do to support Kaizen events, first of all, we create the process data for the Kaizen team. And that can include both cycle time data, and it can also include samples of standardized work data. So if you've got a Kaizen coming up, you say, hey, Drishti, can you give us 50 samples of the standardized work on the line? We'll do the measurement. We'll come back to you with the standardized work chart that is backed by video. So your people who are running the Kaizen can understand exactly what's going on. And then we'll give you the A/B comparison tools. So instead of having one experiment or one iteration of the process over the course of the Kaizen, you can do one on day 1. We can measure it for you. You see the output, you do it on day 2, you do it on shift 1, or you do it on rotation 1. You can do these very rapid experimentations. And so what ends up happening during the Kaizen is that you get 40 to 60% shorter duration of the Kaizen. So what we've seen is that a 5-day Kaizen goes down to 3 days or even 2 days, because all that time that's spent doing data collection before, during, and after, you don't need to do anymore. The people who are involved, they just focus on solving the problems. Similarly, you don't need as many people because you don't have to have as many people monitoring and watching and trying to figure out the process. The data's all there, the video's there. The data comes in advance. So in advance of the Kaizen, your team logs on to Drishti, they start reviewing the process data, they review the video of the process. Even as they're on their way to the Kaizen, they already probably have a good sense of where the problems are. The data is created during the event, like I said. So you do an experiment. You say, okay, we want to try process B, and we're going to run that for the first 2 rotations. Well, we can measure that, compare that to the second 2 rotations, and at the end of day 1, you know how your ideas have performed, and you have another day to iterate on it. So we have an auto tier 1 customer, a very big one who most of you know. They benchmarked our the Drishti Kaizen methodology versus our traditional Kaizen methodology. And they found that it went from an average of 96 man-hours down to about 33 man-hours. So that's about a 60% reduction in the man-hours required to get the output of a Kaizen event. Now, what they also did is they looked at after the Kaizen. And I think this is actually probably more interesting. So typically after a Kaizen event, what they found is their production ratio would drop. That's the blue line. So they've got a process, they've run a Kaizen, and the production ratio immediately drops while the operators get used to the new process. In other words, there's always some bugs in the process, there's some kinks. Production stops while they all look at each other, waiting for the process engineer to figure out what's supposed to happen in this instance and things like that. And there's typically, as they found, as they accounted for, about 5 weeks where the production ratio slowly gets back to normal. And in order to hit the production targets, they either have to overproduce at some point or they have to run overtime at some point to get to their production targets. Now with Drishti, what they found is the process they modeled immediately caused the production ratio to jump. So when I say production ratio, what I mean is the theoretical output of the line compared to the actual output of the line. So traditionally, the production ratio would drop after a Kaizen event. What they validated is that after the Kaizen event, the production ratio would increase. The new process they put in was not only as efficient, but actually more efficient because it was modeled better. And again, I don't think there's any secret to this. When you have better data, and when that data is backed by video, you can get a better outcome. And in this case, you get a more intuitive process that the operators could understand right away. And the data here shows that. So I'm going to do one more set of use cases, and then I know we're kind of on the bottom half of the hour, then I'll open up the floor to questions. Oh, actually, before I do that, I forgot, I want to talk about this. So here's another case study. So we have a customer that was making, let's call them consumer electronics. You can see here's what the line looked like before the Drishti Kaizen. They had 5 operators on 7 stations. They wanted to optimize the line ahead of the demand increase that they predicted for Q4 19. And they wanted to reduce the direct labor cost by 17%. So to prepare them for that Kaizen, we gave them 200 samples per station of data and video. So standardized work charts backed by video to help them understand exactly how the process was performing down to the process step and where each process step was most variable and also the standard deviation of each step. So you could see which steps were the most opportunistic to improve. Where we netted out with them is we got them down to a 35% reduction in direct labor costs. We brought them down from 5 operators to 2 operators. So that's a 60% reduction in labor. Attack time went up a little bit, but we got that 2x the direct labor cost reduction than they expected. Again, there's nothing magical about this. You have better data. You can make things happen faster and more efficiently. That goes for direct labor as well as indirect labor. And there was a 2x improvement in indirect labor efficiency because the Kaizen didn't require as many people. So effectively, it's a 4x lift in the Kaizen just because you have the data is created for you, and the data is backed by video so that every data point becomes very rich. Okay, so let me talk about the third one, systematically reducing defects. We make it simple to retrieve video of any station activity, which lets you quickly identify the root cause of any abnormality and then determine the countermeasures to eliminate the abnormality at its source. So to put it more simply, whenever something happens in the past, whenever you see some sort of abnormality, you can very quickly understand the cause of the abnormality so you can put in the appropriate countermeasures. And this kind of, let's call it a virtuous cycle of finding problems, identifying them, and fixing them has been transformative for our customers. And let me give you a couple examples of how it works. So if you're a quality engineer and you know there's an issue on the line at some point, there's a couple different ways you can do it. It's like YouTube. So you can see the interface on the screen. You can say, show me everything that happened on Tuesday, on line 2, on station 3, between the hours of 3 to 5 p.m. And you click the button, and just like that, you filter the results to the time period you're looking for. You can sort the results by the closest to mean. You can sort the results by the most deviated from the mean. So you can see both the best examples and the examples where operators are struggling with the process. What this helps you understand is you can figure out exactly where your process is causing problems for operators. Or let's say you have MES integration, you can type in the serial number of a unit. So if a unit fails in testing, or if a unit fails when it goes to the customer, if they find a defect, you type in the serial number and you can instantly watch the video of that unit being assembled across all the stations. So you do this, you say, oh, it looks like at station 3, the operator forgot to put in the gasket. How do you solve that problem? Well, previously, you wouldn't know which operator forgot to put in the gasket. You wouldn't know what you had to do about it. So you would probably have the entire team there for a half-hour of training on the proper way to put in the gasket. Without Drishti, not only that, you would probably have an extra quality check that you'd want to put in to make sure the gasket is there, in which case you're adding to cycle time, which means you're basically reducing your throughput, and you're either going to sell less, make less revenue, or you're going to go into overtime to produce to your targets. There's this cascade of things that happen. Now with Drishti, you know exactly what happened, you know exactly when it happened, you know exactly where it happened. So the simplest countermeasure is you take this video, you go to the operator and you say, hey operator, look, you forgot that gasket. Now, I don't know, I guess football season's over, but every time you see during football season, Tom Brady throw an interception, you would see a video of him on the sidelines after the break, looking at what he threw and learning from his mistake, and he would never make the same mistake twice. And it's the same idea. When operators have the chance to learn from the past, they don't make those same mistakes. It's like if you're taking golf lessons, they show you a video of your stroke. You've been practicing the stroke for 20 years, but the second you see video, you start to understand where your problems are. And that's exactly what happens here. Having the data to pinpoint an abnormality, and then having the video to use to show somebody to learn from their mistakes, is creating defect reduction and creating adherence to standardized work. It's really incredible what we're seeing, some of the results from our auto tier ones, especially this defect reduction. And how does that pay off to you? It means that your customers are more loyal. It means you're going to increase your revenue, because when you're known for having not leading quality, but best in breed or better quality than all your other competitors, you're going to keep your customers and you're going to get more customers. So this is the key to using quality to actually improve the state of the company. Let me give you another example. How are supervisors or trainers using it? So I've kind of alluded this to the past. Remember I showed you this slide a few minutes ago where the supervisor can see the defect almost as it occurs, or see the abnormality almost as it occurs. What they're doing with this is they're taking that video and they're going to the operator and they're just showing it to the operator. Hey, 5 minutes ago, this happened. Instead of doing that, you should have done this. There's no emotion. The operator doesn't argue. The operator doesn't feel like they're having their finger pointed at them, because the truth is right there. And so you have a very practical, dogmatic discussion about what is the defect and how do you resolve it. And the operator learns and you move on, and the operator probably won't make that mistake again. Similarly, you can take this data and you can give it to the product designers. And so back to the quality engineers, when the quality engineers are able to isolate the defect in video, they can give that data back to the product designers and improve the product for the next iteration. Toyota Production System tells us it's good to catch defects, but it's better to eliminate defects at their source. And that's what this data is doing. It's helping you eliminate defects at their source. Sometimes the source is the operator, sometimes the source is the product, but you can get to that truth quicker, so you can get down to the defects quicker. Another good example of how quality data is being used, we had one customer where their customer, which is a Japanese auto OEM, called them up and said, hey, we found this defect in this product. We got to figure out what you're going to do about it. So here's the example. The people, our customer, got off the phone. They spent 3 minutes looking for the video of that defect, and they found it in 3 minutes. They spent 19 minutes devising countermeasures to make sure that defect would not happen again. And then they called back the customer 22 minutes later and said, hey, customer, here's video of that defect actually happening on the line 3 weeks ago. Here's what we're doing about it. And the customer is perfectly happy. That's a transformative relationship. You compare that to the status quo, where the customer would probably send a bunch of auditors in some cases to spend time on the line and helping you improve your process and putting in a bunch of criteria that you now have to meet. And that's going to cost you time, that's going to cost you money. When you're able to give quick answers to your customers, you change everything. So another example is when they find a defect, typically what they would do is they would go to the warehouse to check all the other units that came off that batch to make sure that their exposure is not 1 unit or not 1,000 units, but just 1 unit. So you spend a lot of time and energy going to the warehouse, checking units to make sure there's no other defects. So with Drishti, let's say you realize that the source of the defect was on station 3 on line 2 at 10 a.m. Well, I can very easily look at all the other units the operator made on that rotation and check to see if the operator made that mistake on any other units. And now I know my exposure without having to go to the warehouse, without having to tear things down. They've estimated that they saved 20 warehouse trips using Drishti video search. The cost of that could be astronomical if you look at it in terms of labor cost and time wasted. Instead, it's just happening very quickly. Warranty validation. So we were talking to a cabinet manufacturer last week, and they said that what happens is the cabinet's made in the factory, it's sealed up in the box is shipped to the site where it's going to be installed. The box may be opened right then and there, and then the cabinet might sit there on the ground for a month until the contractor actually gets around to installing it. Well, every month that it's sitting there, every day it's sitting there is a day that someone could drop a hammer on it, or someone could spill soda on it, or someone could walk by it and scratch it. And you know what's going to happen. And they know this, they have the data. When they find the defect in the cabinet, even if the contractor called it, they're going to call up the manufacturer and say, hey, you're missing this part, or hey, you've got this scratch, or hey, you've got this defect, or the drawer is broken. And the customer is always right. Well, now we can validate the warranty, because if they can go see the video and prove that the assembly actually took place and that the product was defect-free when it was put in the box, that changes how you're going to approach this warranty issue. You may show it to the customer, you may not, that's your choice, but the point is you have the data to understand what really happened on the floor. Okay, so I'm gonna wrap this up and open up the floor to questions. How can there be so many use cases? That's a question we get a lot, and I've listed just a handful of them that we're seeing our customers. We haven't even talked about NPI, but NPI is a major use case for us. The answer is because this data has never existed. When you have this kind of data, all the people in the factory who used to be desperately trying to find this data now have the data at their fingertips, and they're able to make very quick decisions and improve a lot of elements of the factory. So the second question we always get is, what happens next? So there's a very simple 8-week pilot program that we have. We actually have 3 Q2 spots left. We're more or less booked up in Q1. So if you're interested in talking to us about a pilot, go to drishti.com/pilot and type in the form. Or if you want, you could even just submit it as a question, put your contact information, and one of us will contact you. That information is private, it only goes to us. So if you type in as a question that you want us to contact you, I'll ask one of my team members. Thank you, very good. Someone did that already. Yeah, I'll ask one of my team members to reach out to you right away. In terms of deployment, and by the way, if you have questions, now is a great time to type them into the question box because I'm gonna get to the Q&A session. Deployment of Drishti, of all this technology, is actually quite simple considering how much of an impact it makes. As long as we have a camera in there that has a view of the process, then that's all we need. You don't have to redesign your stations. You don't have to redesign your process. You don't have to put in heavy equipment. No special gloves are required. No AR glasses, no specialized training. We've actually, and this is a really important point, you don't need to hire data scientists or computer engineers. We not only create the data, but we give the data in a form that anyone on the factory floor can use it to make better decisions. And that's a really significant point, because a lot of Industry 4.0 technology requires you to build your own apps or hire data scientists to interpret the data, and we're doing all of that for you. Okay, questions. So the first question I've got is, what about privacy? That's something we hear a lot. Oftentimes executives are very worried about how operators are going to react to being captured on camera. The answer is that yes, it's true that privacy is a concern. And if my boss were to put a camera above me, I would feel very uncomfortable about that unless I got some benefit from it. So the first thing we do before the cameras go in, we explain to the operators what the cameras are doing, what they are capturing and what they're not capturing and what they're not doing. They're not being used for punitive purposes. They're not being used to spy on you 24/7. They're not even really looking at the person, they're looking at the process. And what the operator appreciates, there's two things the operator really appreciates. One is that the operators generally know how the process is failing them, but they don't really have the ability to communicate that failure back to the process engineers, the process designers, or the supervisors. So in other words, I know that materials flow is giving me a problem, or I know that this part of the process is really hard to perform, but it's very hard for me to communicate this. And oftentimes I get blamed as an operator for parts of the process that let me down. So now the data is there. The data in the video is there, and the proof is there to show it's not necessarily the process, it's not necessarily the operator, it's the process that's letting people down. And operators really appreciate being able to feed their wisdom and their knowledge back into the system. The second thing that they really appreciate is having a source of truth. We talked about this a second ago. It's a very intense environment on the line, and snap decisions are made, and operators often get blamed for things they didn't do, or they're forced to sit through unnecessary trainings because they couldn't figure out what really caused the problem. And so now all these things go away because the truth is there and becomes a very collaborative discussion about the truth. And then the third thing is operators understand that the health of the business and their jobs effectively depends on how well they perform them. They see Drishti as an investment in people, not an investment in automation. So Drishti, our mission statement is to extend human potential in an increasingly automated world. So our job is to help the people achieve achieve their full potential. And oftentimes that's significantly more potential. So from the operator perspective, we're actually making them more viable and more valuable to the company. And that is actually helping them improve the conditions in which jobs are created. There was another question earlier that I'm going to go to. And I hope that answers the question. If it doesn't, please somebody speak up and we'll work on that in a second. I guess I can't find the other question. Okay, so the next question is IT. What is it says minimal ongoing IT and facilities engagement. What does that mean in practice? So Drishti requires about 2 megabits of upload speed per second per camera. So what we've learned from our customers so far is that installation, it's not really a technical issue. Most factories have the bandwidth, definitely for the pilot, and sometimes even for running across the entire factory. Sometimes you have to call up Comcast and get a second line, but generally it's not an issue to run a pilot. So most factories have the bandwidth to run a pilot. And if not, getting bandwidth is just a matter of going through procurement and getting extra lines. What really starts to happen is that it's more of an IT permissions issue. And so we tell the customers who work with us to engage IT early, make sure they're aware of what we're trying to do, and usually it's very smooth. It's really not a burden compared to a lot of the other solutions that we've seen. Again, if you think about it, the one thing that supervisors or plant managers don't want to do is they don't want to change the process. And if we can put in a solution and improve the process without first requiring them to install heavy equipment or change the process, all they got to do is call up Comcast and get a line. That's really attractive to the customers that we're seeing.
Dave,
so
we have a few questions in the chat box. Do you want to start with Rohan? Can you elaborate on the metrics about ROI and how are the cost savings calculated?
Mm-hmm. Yeah, okay, thank you. Thanks, Rohan. So can I elaborate about the metrics of ROI? So let me go back to this slide. So ROI takes a lot of different forms. And we actually, when we work with you, we have our head of data meet with you to actually help you guys build the business case, because it's not a standard business case. Oftentimes you build the business case by saying, we're going to reduce direct labor by 10%, or we're going to increase quality by 3%. In this case, there's a lot of interrelated benefits that you start to see when you have a data set like this. So for example, if I can tackle the causes of variability, that's going to pay off both in terms of productivity, but also in terms of quality. it's also going to pay off in terms of travel costs and time on the line. Because if especially those of our customers who have clean rooms, if I can get to the line and observe the line without actually having to go through the clean room, I'm saving 15 minutes on either side. Or in another case, I've got a facility, we have one customer, they have 15 buildings. And to travel from one building to the other takes 15, 20 minutes. Now there's a tremendous ROI in time saving. It's a little bit less tangible, but it's very real. So you can see on the screen on the lower half of each of these columns where we are seeing the most common sources of ROI. Oftentimes the ones that are most important are the ones that are much harder to measure. For example, we have one customer, like we said, has had significant quality improvements, and their customers are well aware of these quality improvements. And what that means is their customers are more likely to come to them with expansion and with new deals. So there's a direct line between quality and increased revenue. And there's a line between Drishti and that quality. If you make the case and suddenly you say, wow, I want a $10 million deal because we increased our quality. That's the kind of thing that we're seeing. Thank you. So next question, and I know we only have about 9 minutes left. What is the hardware requirement? So let me go down to this slide. It's actually very simple, and it's even simpler than you think. We install a camera. It's a simple, straightforward camera like the kind you would see in the ceiling. You may already have them in your plant. We install that, and we actually provide the hardware as a service. So part of our service is we provide the hardware. That way we can, as camera technology advances, we can put in new cameras. And that's really it. You put in a camera, and as long as the camera can see the process, we can create data. There's also some, we put in like switches and routers and a server in the server room to collect the data, but that's really it. I'll compare that to a lot of other places where you have to put in devices to collect data from every machine, or you have to put in specialized hardware that forces you to move the line around. None of those are the case with Drishti. It's designed to be non-intrusive. The operators don't have to wear special gloves or AR glasses or do anything like that. It's designed to be as non-intrusive as possible. Okay, next question. Does the operator have to be stationary and perform a single action repetitively for Drishti to work? Or can the AI pick up multiple actions an operator performs depending on product type? So that's a really good question. So let me explain that. Currently, we need the cameras to be stationary, pointed at work that happens in a predictable location. So that's why we're focused mostly on discrete manufacturing today, because we look at station by station work. It doesn't necessarily mean that the unit has to be in a fixture, or the unit has to be in a totally predictable location, or that the unit can't be, a small cabinet and then a large cabinet and then a small cabinet again. We can handle all of that variability, but we need the work to happen in a location that is predictable. What was the other question? Does it have to be repetitive? It depends on the type of data that we're trying to create. In the most repetitive processes, the auto companies where it's a 30-second cycle time doing every single step exactly the same over and over and over again, we can actually recognize individual process steps. In other more variable environments where the operator might have a mix and they're doing things differently, we can't necessarily measure every single step, but we can certainly measure when the cycle begins and the cycle ends. And we have ways to use that data to isolate which steps are causing the problems, even if we're not creating specific continuous data on individual process steps. So I think that answers your question. So the broader question, I think, is, are we generalizable? Are we able to work in very different manufacturing environments, high mix, low mix, high volume, low volume? The answer is yes. And we provide different kinds of data. And of course, those environments have different kinds of needs depending on what they're making anyway. So we effectively work with the customer to make sure that the data we're providing is oriented around the needs and the problems that they're trying to solve. So are there any other questions so far? This might be the last question, and it's about other use cases.
Dave, we do have one more question in the chat.
Okay.
How are the largest automotive manufacturers currently solving the problem of human assembly errors?
Oh, that's a great question. So we can leave that one, and that can be the last question today. So how are the largest automotive company solving human assembly errors? The answer to that, it's really just very simple. When there's an abnormality, they're able to very quickly understand the root cause and figure out the appropriate countermeasure. So it's kind of like at my old company, our head of customer experience had a saying that she wrote on her whiteboard. It was, gentle pressure continuously applied drives change. So every day you're finding the abnormality, every day you're gently solving the problem, and every day you're seeing incremental change. So every time there's a defect, for example, an operator can learn from it. Every time the process falls apart, the process engineer can learn from it without having to spend days and days on the line trying to figure out what happened. And it's just this knowing what happened in the past so I can improve the future is really at the heart of Drishti. And if I were to leave you with anything, well, the two things I'll leave you with is, one, that's really the best way to think about Drishti, is we are helping you learn from the past very quickly so you can improve it in the future. And then the second thing is, it really is a very straightforward piloting program. And again, a number of you have already raised your hands and said that you're interested in it, and we'll contact you today. But we do have capacity constraints, and after our next big announcement next week, I expect a lot more demand as well. So now is the time, definitely, to get your request in today. We'll call you as soon as we can, and we'll start having the conversation. So thank you very much for your time. I really appreciate it. I'll give you 3 minutes back at the top of the hour. Here's my contact information if you have any questions for me. Otherwise, just go to our website and you can find us, and we'll post these slides in a few days, and you're well, or maybe even sooner than that, and you're welcome to share them with your colleagues. Thank you very much.